Welcome everyone to the Fall 2024 showcase that's being hosted by the Department of Aerospace and Mechanical Engineering for the students within the Mechatronics class. Today, Group 2 would like to present their project, the Safety Helmet 5.0, which involved Baldo Fuentes, Eric Alonso, Santiago Garcia, Giselle Barrios, and John Smith, and of course, Professor Arufur Khan. As you can see to the right, these are pictures of our model. The main objective of our project was to improve the functionality of the protective shield or the visor to be in the proper placement and consistency that will follow OSHA standards, as well as detect unsafe levels of carbon dioxide present that will warn workers of unsafe working conditions to evacuate the premises. Why is this needed? Well, eye protection is ranked ninth out of the top 10 OSHA violations that occur in the work environment, and respiratory safety is ranked fourth out of 10, according to U.S. Bureau of Labor Statistics, taken on March 31st, 2023. With this in mind, our project went through three different design stages before reaching our final product. In our first approach, we originally thought of using a light sensor to trigger our servos with the gear system to move the visor to a designated position, providing a hands-free system. However, we realized that this design would be limited to specific trade work. In addition, the possibility of it malfunctioning would be very high. For example, if a night crew were to be using our helmet and say a flashlight or a spotlight would reflect off the helmet, it could cause it to operate wrongfully, making our individual using our helmet exposing their eyes to the job site, which is what we are trying to avoid. Lastly, Khan recommended using an actuator to help elevate our project, which leads us to our second approach. In our second approach, we decided to use a touch sensor and added a smoke sensor, a buzzer, and still incorporate the original servos. The touch sensor was meant to replace the light sensor in triggering the visor to lift or be pulled down with the actuator to the individual's needs. We took Khan's recommendation and with the smoke sensor to target the unhealthy levels of carbon dioxide that could trigger the buzzer to ring. Although this function was efficient, we were recommended by Khan to include a voice sensor to try and bring back that hands free feature originally thought of in the first design. So finally, it leads us to our final product. Using a voice sensor that triggers the servos to lift or pull the visor to the wanted position, which now guarantees a hands free feature, while operating the smoke detection system with the buzzer ringing if there is unhealthy levels of carbon dioxide detected. For our list of components, we included a safety helmet, a breadboard, wiring, a voice sensor that measures between 65 to 75 decibels, a smoke sensor that measures between 200 to 10,000 parts per million, two servos that are 9 grams that can move 90 degrees, an Arduino code, two 3D printed gear systems that operate at 45 degrees, and a buzzer. In our function flow diagram, you can see there are two separate functions. In the blue part, it's for our gas sensor. As you look towards the right, it detects or it's stated that if carbon dioxide gas is detected, if yes, the buzzer will turn on. If carbon dioxide is not present, then that will mean no, making the buzzer remain off. And this operates as a closed loop system, constantly surveilling the premises to see if there's unhealthy levels of carbon dioxide. On the second function seen in the brown is for the voice sensor. So the voice sensor, as you look towards the right, operates with two commands, up and down. If the command is up, the visor will lift up. If the visor or the command is down, the visor will go down. And this as well operates in as a closed loop system, constantly waiting for a command, giving that hands-free feature to the men or woman wearing the helmet while they're working on the site.
Down.
In conclusion, this project allowed my team and I to think critically as engineers and create an original idea design that could be beneficial in a real world setting. Likewise, our system was enhanced and redesigned three times within a 9 week schedule with full operation and steady workflow. When comparing all three designs, the second attempt was the most functional and efficient. However, we decided to present the third model based off Dr. Khan's recommendations of having a hands free system, which in the end is more beneficial for the men and women working on site because it allows them to think less about making sure their safety gear is on, following OSHA standards, and allows them to focus at the job at hand. In the future, our goal was to design a model that could be adaptable and used by any trade or for various job sites or scenarios. And we hope this model can be incorporated to the work field soon. But due to the time constraint and low budget, it's a good prototype to the future product that can be developed. From Group 2, we would like to thank all past professors who have been part of our journey up to this point. We appreciate the education we receive and look forward to using all the lessons taught to us and putting them into practice, not only for this project, but for all future milestones as we approach and develop into our careers as engineers. On behalf of Group 2, we'd like to say thank you to everyone who listened to our presentation, and we look forward to seeing you soon.